I'm a director of IP transport technology. Then for about 2 years, so I gave a presentation about a disaggregate IP transport network, but we are focused on the kind of the architecture. However, today's I changed the topic. Then today I rather speak about a kind of the device. So I'm happy to speak about this topic. Then this is the really first time for us to have a presentation except in Japan, actually. So I'm so sorry, guys, who listened to my speech yesterday. This is exactly same page. So this is NTT's organization. We have a residential business, and the others, the global NTT communications and the dimension data. And we have also the mobile company that's called NTT Docomo, and NTT Data provided kind of the solution. So NTT has a holding company, and I think this is kind of unique. We have a R&D section in holding company. So I'm in here. So first, just talk about utilization of a white box switch. As I mentioned, we are focused on the IP transport technology. Then we try to disaggregate and integrate and to introduce this kind of architecture to the commercial network. So we of course use a vendor pizza box switches as a fabric cluster and using the controller. And at the same time, we are really expecting for these kind of white box switches. We started to evaluate these kind of network OS for white box and white box kind of 2 years ago. So what is the merit? So we can select the favorable network OS. Then we can use the same box. For example, I think, so after we develop the kind of fabric hardware, then we need the other function just to change the network OS. We don't touch any, the hardware network itself. So then we are tackling that how to enhance the features which carrier need and the performance and the stability. However, how about comparing to the vendor pizza box switch? Unfortunately, so software doesn't have such kind of the mature features and the scalability and the stability. About the hardware, so kind of the same. They are using the same ASIC, so kind of almost same reliability. Then we found, so why we gave our request to the partners who provide vendors, who provide a white box network OS. However, we felt that kind of a limitation. Only one carrier request this kind of requirement. That's not enough. So how to break it? We are tackling the two things. So one is open community activity. The second is to gain our own, knowledge about a white box and OS. So today's topic is focused on this topic. Then the other is I spoke yesterday. Then just introduced a little bit. This is a kind of architecture of the disaggregated image. Now we using the big vendor-specific router and vendor-specific optical. Then after disaggregate IP transport, so this image is like this, using the management of this kind of equipment, so we can introduce this fabric. So not only IP transport, but also we want to disaggregate optical. Then, so this is just one idea. So instead of the only switch as a border leaf. So we use the white box switch, including transponder. So we believe we can make a kind of a small start service. Okay, let's move on to today's topic. So this is a white box image. Then using the same hardware, as I said, we can select the network OS. So from 3 years ago, so we tried to make our own network OS like this. So this time, so we can make our own feature or something. So this is an initial approach. So our image of the IP transport disaggregation, so that's from the data center. So thanks to data center architecture, we can introduce this kind of a switch fabric using the controller. And here is a very good hardware and software also. Then just we try to make it for the carriers. So here is a hardware. And for carrier, this is one example. However, so we need an MPLS for the providing VPN. So here the hardware has this kind of a function. Here is a software. However, just a limited major vendor providing these MPLS functions. So we decided, let's start to make our own network OS. So this is the image of our architecture. So first, we choose Broadcom chip. Then we try to search which kind of interface is best, but we couldn't select. So, OFDPA, which Broadcom are providing, this interface was only one open interface provided MPLS function. That's why we chosen this interface. So our concept is we use open source and free software as much as possible. Then we choose the OFDPA. We have to select the OpenFlow agent, and above that we use an OpenFlow controller. Then about IP protocol, we choose the FRR that was called Quagga before, and we need BGP. So then now we made our own network OS, so as small as possible. Then about 2 years ago, so we just called a P function. So used in the defined spine architecture's spine switch. Then last year, we made a PE function on this leaf switch. So this is a current image of our network OS. So our aim is not to make our own network OS for the business. So this aim is to know what is the white box and what kind of a part is difficult to introduce the network OS for the white box. So to accelerate this movement, so not only the Broadcom chip, but also we adapt to the servers on the servers using the OpenFlow interface. So this year, last March, so we tried to introduce that northbound interface. Then I chose the sysrepo by DT because just one reason is we had a very tight collaboration with DT. So then using sysrepo, now we made a coding about netconf and openconfig. So just last month, we developed adapt to not only the open OFDPA, but also the open NSL. I mentioned it later. So we developed this kind of a network OS. We want to know this network OS feasibility. So NTT around this section has this kind of an environment. Then the other sections using for testing their own R&D product and project, including the other NTT communications or the other residential companies. So this network OS and including these leaf spine switches, including the vendor pizza box. So this kind of environment are moving. Then, so first, we introduce our network OS to this environment. Surely, we have several times a kind of a failure and software bugs. So withdraw, introduce several times, but fortunately, they're very easy to fix because we made this OS, so that's a very good news. Then for 1 year and a half, this network OS kind of stable and moving. So this year, so we expand to the Kuala Lumpur. So this is our subsidiary. Dimension Data has a showcase. So if you have chance to go to Kuala Lumpur, please stop by their showcase. Of course, you have chance to come to Japan. I introduce our environment. Oh, okay, made a mistake. So this is so what kind of knowledge we gained. So here is a positive, possible aspect and a challenging aspect as careers. So positive is the equal discussion with the vendor, I think. So we realized using the open source, so it is really flexible to deploy and develop. And this is we realized that difficult point. So key is how to control the tables of the ASIC. So because the ASIC is a kind of a limited resource. Then what is a challenging aspect? So this news is a very good. So we reconfirm the partners who provides a network OS for white box to scale and importance. So this here is an example. So we realized that very difficult to raise the performance. For example, just the redundancy, the time or something. And we realized also not only the ASIC, but also here is a CPU and the memory. So using this kind of many components of the OSS, so very difficult to make the software small. So this is just information for you. So here is a concern of OSS. Maybe you realized. Then, so we can get the OSS from the internet. Then these OSS are very fast to make an update, including the fixing bugs. So we can easily, update our own OS. However, we are carriers, so we have to have a verification for the very huge testing items. So now we are trying in the automatic verification way. But even we have the very stable OSS. So after we introduced this kind of OSS in the carrier's commercial network, however, we cannot update. I mean, it's very difficult to update because we cannot connect to the internet directly. Then this is a very important point. This is third point. This activity is very dependent on the open interface of the ASIC vendors. So please continue to disclose this kind of interface. I want to ask the ASIC vendors to do that. So this is a trial. So now we are doing, as I mentioned before. So try to make so this title is to enhance scalability, but there is including the negative meaning. Broadcom stopped disclose their own open interface, OFDPA. So I have to change, we have to change the other interface. So we searched and we decided to use Open Network Linux, Open NSL. So in this architecture, so we don't have to use OpenFlow agent, OpenFlow controller. Just we made a small software to call function library of this OpenNSL. So in this architecture, kind of a shortcut, then in this certain test items, so we recognized about 20 times speed up. Okay, so this is the conclusion. So carriers fortunately gained this kind of knowledge and realized importance of the partners who provide a network OS for white box. So now I think we realized that we established this kind of equal, the relationship. So we never just say that that's a requirement, but we know now the contents of the switch. So we can say that very exact, clear requirement. Then, so we are expecting for them. Then this is last. Please, say it again. So we need an open interface of the ASIC to accelerate and this kind of approach of carriers. This slide is not only the thank you, so indicated this URL. So I'm not a specialist to make this open source, actually. So they are in Japan now. So if you have any questions about a technical, and if you have any interest, please visit this URL, and please ask anything. Thank you.